Good morning. Today we will study about time domain analysis of first order system. So we will consider a very simple system, a first order system. Okay. So let us recall what we have learned in the last class. Let us consider any system. Let us consider any system with the transfer function g of s. If the input is r of t, what we want is we want the output c of t. We know that the transfer function is cs by r of s. We are not very happy with c of s, but we want c of t. That is how the output is varying with time. That is what we are interested in. So we know what we are interested in. We want output. That is what time response is all about. You have a system, you give an input to it, you want to get the output from the system. So one way is you can do experimentally, another way is that you can do mathematically. We know that you find Laplace transform of the input, you will get R of s. Once you know R of s, you can multiply it with g of s, you will get c of s. Once you get c of s, you will get c of t by taking L inverse. So that is the agenda. So I am repeating it ad nauseum. Why am I doing it? It's so important. Okay. So we'll get what is c of s? G of s into R of s, and c of t is L inverse of c of s. So our journey is what? Our journey is we have R of t. From R of t, we want c of t. So in this journey of finding time response, what we do is we will take tabak and tabak. We will take step by step. Okay, we will take one step after the other. So let me tell you a story. Okay, in school, what we did, like in first standard and second standard, we learned how to add two single digit numbers. Then what do? You learned how to add two digit numbers. Then once you know how to add two digit numbers, in principle you can add any number. But we know that if it is a 100 digit number, adding will become a little difficult by hand. We have computers to do addition of 100 digit numbers. So same with when you learned binary addition, you learned how to add two single bit numbers, then two bit numbers. So similarly, what we are going to do is, we will in this class, we will learn how to find time response of not any system, we will learn how to find time response of first order system. So this is a first order system, this is a typical first order system. A typical first order system is represented by 1 plus st. We will learn why we have taken this later on. We are considering a typical first order system which is represented by 1 plus st. So what is, how will I find time response for first order system? What do you mean by first order system? I should tell you that a first order system is a system which is represented by a first order differential equation. You know that many systems could be represented by first order differential equation. When you take Laplace transform, there will be one d by dt. When you take Laplace transform, there will be one s. So one example is RC network is represented by first order differential equation. We will see that shortly. So we will consider, so in short, you can think a first order system is a system with one single s in the denominator. 1 by 1 plus s2 is a first order system. 1 by 1 plus s10 is a first order system. So we will focus on first order system. Why? Because things are easy. So we are going to do it very slowly. I want all of you to understand how to find time response of a typical first order system. Time response means you give any input. you give any input, I want the output. So initially in this part of the presentation we will focus on step response. Step response means R of t will be step. Then later on we will learn about impulse response and ramp response. So step response of a typical first order system. What do you mean by step response? You give a step input and get the output. So we know the steps. I am repeating it again. You know R of t, you find R of s. Then you find CFS. Once you know CFS, you take L inverse of CFS, you will get CFT. So this I want all of you to be very clear. Okay. So let us go to the next slide. So what is R of t? For step input, R of t is U of t, unit step. And we know that is why I told you Laplace transform is important. We know that Laplace transform of step is 1 by s. So we got R of s. What is next step? Find CFS. What is that? GFS into R of s. It's straightforward. What is GFS? GFS is 1 by 1 plus st. So I did that algebra. This 1 by s I have taken. This is 1 by s I have taken and put it over here, R of s. Then I got it as 1 by 1 plus st into 1 by s, which I have written neatly as 1 by s into 1 plus st. So what is CFT? CFT is L inverse of CFS. That is our step 3. And that is why we gave a lot of emphasis on Laplace inverse. You should be good in finding Laplace inverse. That is doable by you. I want group leaders to take care of this. So you should be good in finding Laplace inverse. Okay, there is no excuse for that. Okay, so I will do one problem. So let us do this because it's very important. I thought I'll leave this as exercise. Then I thought I will explain it quickly. Okay. So CFT is L inverse of 1 by t into s plus 1 by t. What is this algebra? The algebra is as follows. This form is called time constant form. Okay, this form is called time constant form. I told you first order system and capital T is time constant. I'll tell that again later on. We are interested for finding Laplace inverse. We know that Laplace inverse of 1 by s plus a is e power minus at. Laplace inverse of 1 by s plus 2 is e power minus 2t. Laplace inverse of 1 by s plus 5 is e power minus 5t. So we want it in that form. So what did I do? I took this t. I took this capital T outside. When I took this capital T outside, it will become s plus 1. Okay, I am back. So this t I have taken outside. So what has happened? So this expression has become L inverse of 1 by 1 whole divided by capital T into s plus 1 by t. So how do we find L inverse? So this is the problem with video lecture other than online class or direct class. I want you to respond, but here there is no choice. But I'll pause for a while. You think, how will I go about this? Adarsh, think about it. Okay. Anyway, I will tell you the next step. To find L inverse, we should find partial fraction. So this t I have pushed it in the numerator. So this has become 1 by L inverse of 1 by t divided by s into s plus 1 by t. So we have to find partial fraction expansion. So there is no excuse. You have to learn partial fraction if you have forgotten it. So how will I do partial fraction? You take it as this term inside the square bracket. I have written it as, that is CS. We know that this I have written it as CS, which is equal to A by S plus B by S plus 1 by T. So I have to find L inverse of this. So you have to find A and B. First I thought of typing all the algebra. Then I thought that all of you are good in algebra, okay. So you know how to find A and B. You find A and B. It will be 1 and minus 1 in this particular example. So it is L inverse of 1 by S plus minus 1 by S plus 1 by T. What is L inverse of 1 by S? What is L inverse of 1 by S? Is 1. And what is L inverse of 1 by S plus 1 by T? It is e power minus T by capital T, where capital T is the time constant. So let us do an exercise. The transfer function of a system is given as 1 by 1 plus 2s. Find the step response, hence plot the step response. So that is the question. So this question you should do it on your own. You pause the video, do it on your own, and then when in tomorrow's class you should type CFT in the chat box. I want you to be honest, there is no marks for it. So this is very simple, you have to do it, okay. So once you finish doing it, you can go forward. In the question, it was given GFS is 1 by 1 plus 2s. So what is CFS? 1 plus 2s into R of S. We are finding step response. So what is R of S? 1 by S. So it is 1 by 1 plus 2s into 1 by S. So now what should I do? I should write it in pole 0 form. What is that? I'll take 2 outside. I'll take this man outside, this 2 outside. So that 2 is here. So it becomes half by S plus half by S into S plus 1 by 2. Now what will be the next step? The next step is you should write it in form so that you can find L inverse easily. So we should go in for partial fraction. So you have to find L inverse of this. So I can write it as A by S plus B by S plus 1 by 2. So it happens to be A and B happens to be 1 and minus 1. So what is L inverse of CS? L inverse of CS is L inverse of this entire quantity, and inverse is a linear operator. So first I will find L inverse of this 1 by S plus L inverse of this. So I will get the answer as 1 minus e power minus T by 2. So this is the inverse. So in that question I asked you to draw the plot. I want you to understand what is step response. I want you to get the feel of step response. I want you to get the meaning of step response. I want you to know the shape of the step response. So that is why in that exercise I said plot of CFT. So this you could use MATLAB. So this is an expression. This is C of t. I want you to be very clear about this function. This is a function of time. So how will I get the plot? You have t. You have t. You can make a tabular column. You can find C of t. This is how we draw any graph. So you put some value for t equal to 0. What will be this? 1 minus e power 0, it will be 0. You will get a value here. Then you put some other value for t, you will get another value. So I have done this for you. Do it by your own. You have a calculator and tuck tuck you do it, okay, and check the answer. When t is 0, it is 0.0. When t is 0.31 1 second, it is 0.3935. When t becomes 10 seconds, CFT becomes 0.9933. So it's almost 1, okay. And you can see that once t becomes 8, there is no much change in this. Now, how will you plot this? You draw x-axis and y-axis. X-axis is time, y-axis CFT 0, 0. You get a point here. I'll use another color. Then t is 1. Corresponding to 1, I'll get another number. I'll get a number here. Then corresponding to 2, I get this color is not good. Corresponding to 2, you'll get another number. You put a dot here. Corresponding to 3, you'll get another number. Corresponding to 4, you'll get another number, so on. And you can join all those things and you'll get a smooth curve. So after 10, there is no much change about in CFT. So I will be coming to this. So when you give some input, there is a slow change. There is a change in CFT. After some time, there is no change. We say it has reached a steady state. Okay. So I have drawn a neat graph here. So you can see here, corresponding to 1, there is some point 0.3935. It's somewhere here. Yes. Corresponding to 2, there is another point 0.6, and so on. So you join all these points, you'll get, this is called step response. Some things are in order here, okay. So our transfer function was 1 by 1 plus 2s. For this system, the time constant is how much? Time constant is 2 seconds. What does it mean is, it gives you some idea about how long it will take for the response to reach steady state. You know that here in the general expression, it was capital T. So if this becomes 2 angular, once this is 2, when it becomes 10, the expression will become 1 minus e power minus 10 by 2. Minus 10 by 2, all of you know, minus 10 by 2 is 5. And e power minus 5 is a very small number. So what will be this? This will go to 0. So this will become 1. So if t is in this particular example, t was 2. Suppose t was 10. Then when small t becomes 50, this number will become small. If t was 1 millisecond, then when small t becomes 5 millisecond, this number will become 0. So that is why the time constant has such an importance. Okay. So in control system, if you know the time constant of the system, you will know how long it will take for the system to reach steady state. This is called steady state. Okay. This is called steady state. So if you you remember my kettle, I don't have kettle today. You remember I showed you a kettle and boiling water and switching on the stove. What happens is when you switch on the stove, the temperature will increase slowly. After some time, it will reach a steady state. After that, there won't be any change. So you remember another example is thermometer. When you are sick, you go to a doctor. He measures your temperature. How does he do? He don't put the thermometer in your mouth for 1 second and take it out. He put it for 50 seconds or 1 minute. Why? Because it will take some time for the thermometer, the mercury to expand and reach the steady state. So that is the importance of time constant. So another thing is first order system with steady state gain. So such systems are given here. This maybe I will cover in the next class. It's almost 20 minutes. I will cover this in the next class. So we have studied about first order system. We have studied about time constant. We have studied about step response. We know about time constant form. Pole zero form we know. Steady state gain we'll look in the next part of the video. This we'll look in the next part of the video. Thank you. Please do that exercise before you come to the class, or maybe in the class, okay? So thank you.